The final science skill we're going to look at is using the scientific method to answer a question. Go ahead and turn to the next blank page in your notebook, label it Scientific Method Notes. Divide the page into 2 columns. On the left-hand side, big ideas. The right-hand side, supporting details. You can pause the video now to do that. So the scientific method, like the design process, is a way to solve a problem or answer a question. So usually when scientists begin their science process, it starts with some observations, as we mentioned in the last video. Might make an observation, and then the next step is to wonder why or how that happens. Remember, science is the process of describing the phenomena that happen around us. So a scientist might observe something. Oh, look, the sky is blue. I wonder why the sky is blue. And that gets the ball rolling to set up an experiment to answer that question. So the first step in the scientific method is to identify a problem or ask a question based on observations. Once we have that question or problem, we form a hypothesis. Hypothesis is an educated guess about the answer to your question. So it's a possible answer to the question you just asked. And it's educated because it's based on some background knowledge. It's not just random. Usually a scientist takes some time to do some research about their question. So once they have some research, have some background information, they are able to make a reasonable, educated guess. Let's come up with a quick problem here. Let's say I made an observation that my plants that are next to my window are growing taller and thicker than the plants that are away from my window. And I wonder why that happens. Why are the plants growing better near the window than away from the window? And so I might form a hypothesis about that, a possible answer to the question. Remember that when you make a hypothesis, you're going to make them objective, not with your opinions. You're simply basing it on your observations and your background knowledge. You always want to state them in an if-then process, or an if-then statement. And it should be a possible, reasonable answer to your question. So I might say something like, if sunlight affects plant growth, then plants sitting next to a window or in the sunlight would grow taller than plants growing in the dark or away from a window. It's a possible hypothesis stating in the if-then format. If tells me the answer to my question, then tells me how I'm going to test it. So let's get to that next step. The next step would be to take my hypothesis and design an experiment. The experiment is set up to test my hypothesis. Now, some really important components to a good experiment to make sure that the data you collect at the end is good, valid data, and that it can possibly answer your question. So some of the things that we want to make sure we include are both an independent variable and a dependent variable. The independent variable in an experiment is the thing that you as the scientist, the investigator, is going to change or manipulate. So in my experiment, the thing that I'm going to change is the amount of light my plants get. So my independent variable is that light or no light. That's the thing that I am changing, I'm manipulating. Whereas the dependent variable depends on my independent variable. That's the thing that's going to change based on my independent variable. And a really good way to think about it is it's what you're measuring, it's what you're going to data you're collecting. So I always think about it, okay, in my experiment, what am I going to write down? And in this one, what am I going to write down? If I'm worried about, or if I'm wondering about plant growth in light versus dark, the stuff that I'm writing down is the growth. So I'm writing down, maybe I'm measuring the height every day, and I would write down the height. So my dependent variable is the height of the plant. Now, in order to make sure that the only thing that is affecting my data is my independent variable, I really am only testing this independent variable. I want to make sure it's only the light that's affecting it. I want to make sure that I include a control and constants in my experiment. Sometimes these get confused, but a control is the part of the experiment that's used for comparison. So a traditional way to do this would be to set up one group of plants that receive sunlight and one group that are in the dark. So the control, if I'm comparing the sunlight to the dark, the control is the plants that are in the dark. So I'm comparing these two, so I know that it is just the light that is affecting my plant growth. I have to have something to compare it to. And then finally, I want to make sure that all the other factors are kept the same. So only the light is the only thing that's different. So if I'm setting up plants, some of the things that I might hold constant are the type of plant, when they were planted, the type of soil they're in, the type of pot they're in, how much they're watered, how much they're fertilized, how much light or dark they're getting. So all those other factors are remaining constant. The only thing that is affecting my data is the fact that one's in the light and one's in the dark. Once I have a experiment set up, I want to make sure that I have good data to collect. So one thing that is really important is that you have as much data as possible. Usually we think about this as replications. How many times am I doing the experiment? And really the more the better. As reasonably as you can do it, the more the better. So in my experiment, I probably want to try to get as many plants as possible in my experiment. So I want a lot of plants in the light and a lot of plants in the dark. That way I know that there's not just like a fluke, like maybe one plant is just a really strong plant, or one plant is just a really weak plant, and that doesn't just throw off my data. Lots of plants to compare to. Your data, remember, is the information that you're collecting, the numbers that you're writing down, your observations. You want to make sure you organize your data really well so that it's easy to analyze. You want to create a data table before you start your experiment so that you have somewhere to write your experiment. So in this case here, I have my plants that I'm doing, and I'm recording the height every week or something. It's just an example. Finally, you're going to want to analyze your data and draw your conclusions. So I've collected all my data, my experiment is over, and now I have this data in front of me, and I want to say, okay, did the sunlight affect the growth? So if it did, I would say that my hypothesis was supported. If it didn't, I would say my hypothesis was not supported. Bell. Simply based on my data and my hypothesis, it is really important to remember that your experiment is not a failure if your hypothesis is not supported, because you still got an answer to your question. My question was, does light affect it? If it didn't, my hypothesis was not supported, that's okay, I still have an answer. Light didn't affect it. It's great. So really important that at the end of your experiment, your hypothesis is not supported. You don't think that you did something wrong. You simply look at your answer that my answer was no, it wasn't supported. Now I want you guys to go ahead and think about this and try to set up your own experiment. Here's my question for you. Does the type of wood you use affect how long it burns in a wood stove? So you got some wood, different types of trees. You're going to put it in your wood stove. How does that type of wood affect how long it burns? So I want you to write a hypothesis, make sure it's in the if-then format, and then draw out an experiment. Of course, you don't actually have to do anything. I just want you to, or you don't have to actually do the experiment. I want you to write it out. What would your variables be? What would you do to test this? What kind of data would you collect? And we're going to discuss this in class, so make sure it's written in your notebook.